Hello and welcome to Tribe Topper. In this video session, you are going to learn about wavefronts and rays. So what are wavefronts? So basically, a wavefront we can say is a surface that travels along with a wave, and it is always perpendicular to the direction in which the wave travels. We can also call it as the locus of all points that are in phase from the source of the wave. Like here, so basically, if you look at it, like from here, this is a point source of a wave. When it sends out the rays in all direction, then we have some locus of a point which are all at the same distance from the source, but they are all in phase. So this is a wavefront. From here you get the next wavefront, so that's the next wavefront, and so on. You getting these circular wavefronts. So whenever you have a point source of light, you will get the spherical wavefronts or circular wavefronts. Sometimes you also get the cylindrical wavefronts. Like here, if you have something, then you will have the cylinders moving out. So all those envelopes will be the cylindrical wavefronts. You have parallel rays, then you also get these plane wavefronts. So wavefront is basically just a surface that will travel along with the wave. But remember, it is perpendicular to the direction in which the wave travels. This fact will be of importance when you have to draw the wavefronts in a ray diagram. Now, what is a ray? A ray is just a line which shows up in the direction in which a wave is transferring its energy, right? So a ray is a line showing the direction in which a wave transfers energy. And of course, it is perpendicular to the wavefront, as I had already told you, because it is wavefront is perpendicular to the direction of the traveling of the wave, and ray is along the direction of the traveling of the wave. So as you can see here, we have an incident ray. That's a single line which is giving us the direction in which the wave is going to transfer its energy. From the mirror, it gets reflected. You have a reflected ray. And if you have to draw the wavefronts, you will see you just have to draw these lines perpendicular to these. These will be the wavefronts. So let's see if in a question they ask you to draw the reflected wavefronts or the refracted wavefronts, then how are you going to draw them? So the first one I'm drawing are the reflected wavefronts. As you can see, the method, a typical style of drawing a reflected wavefront is that first of all, you should draw the incident ray, mark an arrow showing this is an incident ray, make its angle. You can mark that angle I with the normal, and then you mark the angle of reflection and show this reflected ray. So first of all, you should draw the incident and the reflected ray. Then just draw these perpendicular lines. These are the incident wavefronts and the reflected wavefronts. Now, what about the refracted wavefronts? The rule is still the same. I would suggest first draw the ray, which is the incident ray and the refracted ray. Now, as you can see here, this is deep water where the water runs very fast. The moment you see here, this is the surface, right? You can say this is the surface, and to this I'll draw a normal to this surface. So the ray has gone away. You can see it has moved away from the normal. So your water being shallow here, the speed of the water slows down. So I will write here this side is the slow water, and on the deeper side you have the faster water. Deep water runs faster. So naturally, when it comes from the deep water to the shallow water, just show that the ray bends towards the normal. After that, there is no problem. Just draw the wavefronts, which are perpendicular lines to the incident wavefront, and then draw some perpendicular lines to the refracted wavefronts. And this is how you can draw the refracted wavefronts. And in case of diffraction, diffraction is the phenomenon where your light rays or any waves, they bend around the corners. So you can see these were the plane wavefronts entering. This small aperture, when they enter from here, the rays, they will get bent. So you will see the rays are bent. Draw those waves, and your wavefronts will just turn into these spherical wavefronts. So these are the diffracted wavefronts. So you can either first draw just the rays that is incident and diffracted, and then draw these circles. So these are the diffracted wavefronts. So now they say on a copy of the diagram below, draw a line to complete the wavefront. So to draw that line to complete the wavefront, we just have to take a line which is going to be a line parallel to the original wavefront that they have already shown, the one coming from CD. So just make sure this is parallel to the original one. I'll make it black. So this is your wavefront. So to draw that wavefront, you just take out something which is parallel, because if the original wavefronts were parallel, right, just take care, if the incident wavefronts are parallel, then your refracted wavefronts are also parallel, right? So just make sure that your refracted wavefronts are also parallel. And good thing is they've already drawn one wavefront. The other one, you just have to show a line parallel to it. And now they're asking you, explain in which medium, I or R, the wave has the higher speed. So for that we have an obvious answer, because the parallel wavefronts, the incident parallel wavefronts, were wide apart. The distance between them was far away, but now they are driven closer. That means the wavefronts move closer to each other, so they are traveling slowly in the medium R. So they travel slower in the medium R. And the reason you can give is, as the wavefronts move closer together, because they have shifted closer, so this indicates that the wave has slowed down in the medium R. Okay, that's all in this video session. In the next video session, you are going to learn about principle of superposition and intensity of the waves. Thank you for watching.